this lesson, we're going to go through the fundamentals of how to set up one-point perspective so that you can create the bouncing ball animation in perspective. Now, if you've ever looked at train tracks or tunnels, or you've ever looked at things into the distance, you'll notice that all of the lines of, say, the train tracks or the tunnel you're in or the building you're in all lead directionally away from you into this tiny little point. In perspective, we call that the vanishing point. And in one-point perspective, we have some specific rules about how these things can work. The first is every line needs to be leading away from you towards this vanishing point. And the other rule is that any other object must be aligned with you. So effectively they are standing horizontally or vertically away from you. The moment an object is rotated off this 90-degree plane, then it turns into two-point perspective. And that's not what we're going to cover in this lesson. This lesson is only going to deal with one-point perspective setups. Now this lesson is going to deal with the same bouncing ball animation as in the previous lesson. And if you recall from that lesson, understanding your timings and your spacings are absolutely vital in animation. And those rules don't change for perspective. So on the top right, you can see this is the animation that I'm going to try replicate in perspective mode. And I'm going to choose 12 frames for the first bounce. So there's going to be 12 frames in between before the ball lands here. And then there's going to be 6 frames before it lands here. And then 3 frames. So now I need to find a way of taking this system and bringing it somehow into one-point perspective. Now the first thing you might recall is that we talked about the vanishing point. So I'm going to choose a vanishing point here. Now, for any lines leading away from you, they all need to go towards this vanishing point. Now in one-point perspective, what we're going to do is we're going to start creating some guidelines. And the first is to decide where is the ball in perspective space. So we need to find out where this point is. And the way we can do that is we can replicate this bottom line first. We know from one-point perspective that this bottom line has to be traveling towards the vanishing point. So towards this little dot here. So I've now drawn this line, and this line will be equivalent to this line here. And if I choose this point here, this end point, I can say that is this point. So you can see what I'm doing is I'm transposing this line into perspective. So this line will be our vertical line. So from here to some height here, we can choose, let's say, here. This will be the starting position of our ball. So this point here can now be found here. And now we need to know our keyframes, the key points at which the ball will be bouncing. Now there are ways and means in perspective to work out the exact distances and the exact way, but what we're going to do for the moment is just simply guesstimate in perspective the very first bounce point, the very first keyframe. So we're saying this point here is equivalent to that point there. It is important to say at this point that it's not normally possible to just guesstimate perspective. The reason why we're drawing all of these lines is because we're very poor, as humans, we're very, very poor at guesstimating where something will appear in perspective mode. So aside from this one moment, we're not going to ever guesstimate again. So for the moment, we're going to say this here is our first bounce point. This is where the 12 point is, the 12th frame. So I'm just going to draw a vertical line straight up here. And that's equivalent to taking this point here and drawing a straight line up there. So that's effectively what I've done. And what I want to do is find out where on this point is equivalent to that point. I want to draw this box. And again, if you remember, the rules of one-point perspective is that any lines moving away from us must go towards a central vanishing point. So I'm going to draw from this point to our vanishing point, another guideline. So in effect, what I've done is I have created a box, a rectangle in perspective mode. And this rectangle I've just created is equivalent to this rectangle here. So again, what you can see is I am transposing these lines into perspective mode. But now I have a problem because, as I say, I don't want to guesstimate. I don't want to guess where these points are. What I want to do is be very accurate about how these things work. And in fact, you can see from this drawing, I've actually kind of guesstimated the 6 and the 3 points. But if we actually measured that, the 6 would be about here, and the 3 would probably be where the 6 is. And this is the problem when you freehand these ideas. In animation, you really want to be absolutely accurate about your lining. So instead of guesstimating like I have here, we're actually going to measure in perspective. And there's a really cool trick to how you do that. So we're going to come from the top original position of the ball down to the bottom far corner. And we're going to cross the lines of the box. What we're doing, again in this 2D example, is we're creating a cross in the box. Now this has a really interesting effect, because if you do your math, and we won't go through that now, but if you do your math, this splits the box in half along every direction. So the full length of this box is 12. So each one of these is half of 12. So just by creating a cross in this box that we've first created, we have now found out a way to get the halfway point of this line. So this is halfway to 12. So now if I come to my perspective example, I can select this point in the middle and draw a line directly down. And I can select the line in the middle again and draw a line directly up. So I now know this is equivalent to 6 frames in. And to create this line here, the horizontal line, again we know that every line disappears towards the vanishing point. So this line here and this line here have now split this in half. And if you measure this, if you take your ruler and you measure that, you will find that this is exactly halfway. This is a really good time to stop this lesson and actually draw this system yourself. Practice it, find out how to create this box and split those lines in half. Now, once you have drawn all of this, once you have tried to replicate this system, it's time to work out where 6 and 3 will appear. What we want to do is measure. We want to measure this system. We want to measure where the 6 bounce will happen, where the 3 bounce will happen. And again, there's a really interesting effect that you can use in order to achieve this. The reason why we have initially created this cross is actually this far split here. So it's actually the far side of the square that is now really important to us. So again, this point here has been key. This is why we've created the cross initially. And what I'm going to do is I'm going to take the bottom close corner of the box, I'm going to draw a line through that point, and I'm going to keep sweeping it all the way through to meet on the other side. Okay, and so now you can see I've gone from this bottom corner, swept all the way through up until I've met here on this top line. Now what I've actually done, again, there's a whole bunch of math behind this, which we're not going to do, but I've created a line here that is the same length as this line. Now I will just repeat that in the top right-hand 2D example, where I will split the box and create that second line. So I've now created a box that is equal size. So this box here and this new box here, they are equal sizes. So what that first tells me is this original kind of freehand drawing I've drawn is incorrect, and I need to adjust that. So again, this is a lesson in the dangers of freehanding an idea, because what you're looking at here is another 12 frames on. So this distance here and this distance here are exactly the same size. So now we know if we were to cross this box using the same technique, so if I was to cross here and I was to cross here, this is now the middle, and I can drop this line down here, and instead of this where originally the 6 was, this is now the 6 point. And now I want to know where that 3 is. And the simple trick is to make another box from that middle and cross it from here to here. So there's no limit to how many boxes you create. As long as you know your original dimensions, you can create as many of these boxes as you want. But so now this box is halfway between 6 and 12, another 3 frames on. So now I know this is my next bounce point, and this is my next bounce point, because my original plan was to do a 12 to 6 to 3. And now instead of freehanding it, I have a very direct example. Now, if you didn't follow what I just went through, I'm going to go through it in perspective, and it might make a bit more sense as you watch it in perspective. So to reiterate, we know that this distance here, between these 2 points, is now actually the same as this distance here. Although, of course, if you measure it, it won't look like the same thing, but in perspective, this is the equivalent. So what I'm going to do is I'm going to draw from here straight down. And now you can see these 2 rectangles have appeared. So this rectangle here and this bigger rectangle here. These are the same size, even though in perspective they very much look like they're not. And so now I'm starting to have a system that I have clearly measured, and I know where everything is. And what I want to do is find out where my next bounce points were. And again, to reiterate, we knew that we wanted to have our first bounce at 12, and then the next bounce in 6 more frames. So what we're going to do is we're going to take this line here, and we're going to create a cross in this box. So from the top left hand of this box down to the bottom right, and from the bottom left up to the top right, we are crossing the box. And you can see the boxes create a halfway point that matches with the halfway points of the other box. So all of our measurements we know are generally correct. I could perhaps have been a little bit more accurate, but you can see that in general the measurements are working out. So if I take this point here, which is now halfway, and drop our line vertically down, we know that this point here is our 6 point. So this is our next keyframe bounce. So from 12 to 6. And the last thing we want to do is we want to work out where 3 is. So 3 is somewhere between here. So we've got up to 12, then to 6, and then there's going to be another 3 more frames somewhere along here. And of course, the way we want to do that is to find this box here and find halfway. So I can simply take this line here, and since I already have a line crossing this way, I've just created another cross in this box here, which is again split this line here. And so this is 6 more frames on, and this is 3 more frames on. And so now I have very accurate measurements of where the bounces will be. This would be a good time to try attempt what I've just done. And again, try re-watch it if you do get confused, because when you first start working on this, it is quite confusing to see all of these lines being built and go everywhere. So now try follow along and draw this system out before we go on any further. Now finally we have our entire setup ready. We're pretty much ready to draw our line. But the problem that we face is, again, just like trying to freehand distances in perspective, it's quite difficult to simply draw this curve in perspective. It's a very difficult thing to do. So what we need to do is work out exactly where each of these frames are and then transpose this line into perspective. So really what we want to do is we want to be more accurate with where our frames are. So from frame 0 to frame 12, we don't really know where they're positioned. And so what we want to do is cut these boxes again to give ourselves the positions of each of these frames. So I'm going to go ahead and I'm going to create more guidelines. One thing you'll notice is that when I'm splitting these boxes right now, I'm getting to frame 1.5. And at this point, I am actually guesstimating. I'm guesstimating somewhere between the 1 and the 2 frame, because 0.5 frames are not helpful for us. You can be a bit more accurate if you so choose, but at this point, breaking that down, but 1 frame is not too bad. And so you can see what I've done is I've created the position of the ball in the horizontal direction for every single frame as we go on. And in effect, so what I have done is I've worked out the distances as the ball travels in the horizontal direction. And if you remember from our original lesson, those distances are constant. The ball is moving constantly in the horizontal direction. So even though these are getting closer and closer together, in perspective, this is actually showing a constant rate of motion, which is again why it's so hard to just sort of freehand perspective. And so now we want to know where the ball will, where the actual path of the ball will be going. So even though we've worked out the position of the frames in the horizontal, it still doesn't help us work out exactly where the position of the ball will be. But if we apply our tricks of cutting these boxes in half, we can actually start to work out some really important information. So if I go back up to our 2D little example here and cut the ball again, cut these boxes again in half, what you see happens is these lines, these guidelines that we've created, start to intersect with the path of our ball. So for example, we have our start point here, and then now we have this midpoint which intersects with the position of the path. And that becomes really helpful, because now we can use these to transpose in perspective. So if I recreate these guideline boxes everywhere, we can use those as guides to position the line. So let's say this is now key points in the path of the ball. So if we look at that one, the ball is probably around here. And then we come to this line here, it now finds its way to there. And you can see what I'm doing is I'm transposing general positions of the ball as according to where it is intersecting the guidelines that we've created. And note that the more guidelines you have, the better you will be able to position the ball. So this will now give me a general path for the ball. And from here, I can now use this path and all of the frames that I've generated to draw the position of the ball. Because what I can do is transpose vertically, follow frame 1 all the way up to here, and I now know that at frame 1, this will be the central position of the ball. Now if I move to frame 2, I can follow frame 2 all the way up, and I know that this position here is approximately where frame 2 is. Frame 3 is the central point, so this here is frame 3. Frame 4, frame 5, and so on and so forth. And so now, knowing these positions of the ball, I can now draw this ball accurately and position it wherever I need to along this path. So these are the steps that you can follow in order to draw a bouncing ball in perspective. And in order to draw the last frames, you simply follow the same process. So I would go ahead now and transpose your line using the tricks and techniques that we've gone through here. So once you've transposed your line and you're ready to start drawing the ball in, you have to realize that the ball itself will also get smaller. So if we look at how this works in perspective, we see our line down here. This is the height of the ball. And if we follow this down here, this is also the original height of the ball, because this line here corresponds to this line here. So as objects go further and further away from you in perspective, they appear smaller and smaller. But because we've set up our guidelines, we actually can work out exactly how much smaller it gets. Because as long as you've used a ruler, you can simply measure this line here, and then this line here. And let's say, for example, this line was 10 centimeters long, and this line over here was 7 centimeters long. Well, then you know that by the time the ball gets to this line here, the ball will be 7/10, 7 divided by 10, of its size. So if the ball is 1 centimeter across, by the time the ball gets down to here, it'll be 0.7 centimeters. And so by setting up these guidelines accurately and precisely, you can actually work out just how much smaller the ball will get in perspective, and you can actually work that out for every single frame. And that means you can be utterly accurate when you start bouncing this ball in perspective. Now, once you have finished transposing your lines using each position of the frames that you've created, you should now have something that looks something like this. And as long as on paper, if you've created these guidelines very lightly, or if you've created this digitally, you've used different layers, you can now hide those layers or erase your guidelines, and you'll have a bouncing ball in perspective.